So what exactly is a set? Well, a set is just a collection of things, like maybe the set A, which equals the numbers 1, 2, 3, and 4. When we describe a set, we use a capital letter, and then we have these curly braces here, and then the things that are in here, these are the things that are inside the set. So the set A has the numbers 1, 2, 3, and 4. How about the set B? That has the letters A, B, and C. And we could also have a set like set C, which has banana, apple, and mango. So the idea of a set is very general. It doesn't just have to include numbers. It could include all kinds of different things. The members of a set are called the elements of the set. So for instance, the elements of the set A that we have right here would be 1, 2, 3, and 4. The elements of set C would be banana, apple, mango. To say that something is in a set, we use this kind of notation here. This says that 2 is in the set A. And if you look, here's 2 right there. It is indeed in the set A. This would mean that C is in the set B. And we could also say something is not in a set. Pineapple is not in the set C. -1 is also not in the set C. So this symbol here we can think of as meaning is an element of. So for instance, we could say 2 is an element of the set A. C is an element of the set B. And then we could also say things like pineapple is not an element of the set C. Okay, how do you describe a set? Well, there's 4 different ways to describe a set. First, you can just list the elements, like we did with the set A. That'd be 1, 2, 3, and 4. You could also use a pattern. Suppose you wanted to list a large number of elements, and it would just take too long to list them individually, but they formed a pattern. Like this set D here. This would be the set of numbers 1, 2, 3, 4, all the way up to 1,000. It would take a very long time to go and list all of those individually, but if there's a pattern, then the 3 dots that we use in the middle of the set here, that indicates that you just keep continuing the pattern up until, in this case, 1,000. You can describe the set in words, like the set E, that is the set of integers that are greater than -4 and less than 16. So that would be the integers -3, -2, -1, 0, 1, 2, 3, 4, all the way up to 15. Finally, we can use something called set builder notation. So here's an example. The set F is the set, and then here's how you read this. So here's our set F, and this is the set of all x such that, a little bar means such that, x is a positive even integer. So in other words, this set F here, if I wanted to actually write out the elements, we want positive even integers. Okay, so that would be things like 2 and 4 and 6 and 8 and so on. And so we can keep going. I can do the dots here since I have a pattern. And since it's all positive even integers, I'll just close the set there, meaning it keeps going on forever and ever and ever. Another notation that you might see is this double dot here, but you read it the same way. So again, this would mean F is the set of all x such that x is a positive even integer. There's a few more terms that you should know. A finite set means that you can count the number of elements in the set and reach an endpoint. For instance, the set A. This is finite. I can actually count the elements that are in here. So I have 1 element, 2 elements, 3 elements, 4 elements. This is a finite set, and there are 4 elements in the set. An infinite set means you cannot count the number of elements and reach an endpoint. So for example, that set F that we had before, the set of all x such that x is a positive even integer, well, you can't count them and reach an endpoint. If we look at the elements in the set, remember that it was 2, 4, 6, 8, 10, and so on. It kept going and going and going forever and ever and ever. You would never reach an endpoint if you tried to count the number of elements in the set. Finally, we have something called the empty set, and that's just the set with no elements. And there's special notation for this. It looks like a circle with a line through it. That means the empty set, the set that has nothing in it.